Welcome back, everyone. So in the previous 4 videos, we built this Bluetooth Low Energy application step by step. Now it's time to examine its power consumption. So in this video, we will focus on optimizing the power consumption of a Bluetooth Low Energy application. So where do we start with the power optimization of a Bluetooth Low Energy application? Well, first we need to know the expected power consumption numbers for the sock we're using in our project. Like, for example, how much current it draws or when it's transmitting or receiving. Such information is found in the product specification, also known as the datasheet of the sock. That's one way to do it, but luckily there is an easier way to do it, which is by using the online power profiler that can simplify this process of obtaining the expected power usage of a Bluetooth Low Energy chip in different roles, whether it's central or peripheral, whether it's advertising or in connection. So we will start with the online power profiler tool to get an idea of how much power is expected to be consumed for such a configuration that we have in our application. Keep in mind that these are based on static software model of the SOC and are basically an estimate, but they're basically within 5% accuracy of the real measurement. The next step, after we have obtained some idea of the goal, the target that we want to reach, is to actually measure the power consumption of the SOC using instruments. So for example, you could use oscilloscope, ampere meter, power analyzer. Some of these equipment might be expensive, and that's why luckily again Nordic made an affordable hardware instrument called the Power Profiler Kit 2, PPK2 for short, for this exact purpose. So the Power Profiler Kit PPK2, it comes with a desktop application called the Power Profiler. We will use a lot in this video. And then when we reach this point where we have both an estimation of how much power our application should consume and a way to actually measure it, then we can actually start optimizing the application and make it more power optimized. So in this video, again, we will use the Power Profiler, the online Power Profiler, then connect the PPK as an ampere meter to the development kit, and finally make changes to our application so that it is power optimized and in line to what it's expected from the online Power Profiler. All right, so then let's dig right into it. All right, so I opened the online Power Profiler by clicking on the first link in the slides. I selected the SOC that I'm using, which is the nRF 52840 SOC, since I'm using the nRF 52840 development kit. Select the parameter to match the hardware. Since our application is making the chip act as a Bluetooth Low Energy peripheral, it means it will spend its life cycle either in advertising role, broadcasting its presence to nearby central devices, or in connection mode with a central. And that's why we need to optimize for both scenarios, advertising and in connection. Let's start with advertising. In Bluetooth Low Energy, the advertising interval, that's one parameter we can kind of like tweak here. The advertising interval refers to the time interval between consecutive advertising packets sent by the device. This interval determines how often a device broadcasts its presence to nearby devices. It is measured in milliseconds, and it can range from, I think, 20 milliseconds to up to 10.24 seconds. A shorter advertising interval, something close to 20 milliseconds, increases the discoverability of the device but consumes way more power. While on the other hand, a longer advertising interval, let's say something close to 10 seconds, it saves a lot of power but makes the device less responsive to scanning devices. The default value that I have in my LBS is 100. For my application, so this is again something you pick based on your application, 100 is it's a lot of wasted power, because I can change this to let's say you can see the total average current with this advertising interval of 100 millisecond is 141. But if I change it to 3 seconds, 3000 millisecond, the device, you'll see it's still responsive, it's still be detectable, and it still behaves as we did before, but it consumes way less power than before. So that's one of the tricks we will do in this video. which is optimizing the scenario where the device is in advertising role, which is going to be a lot of its life cycle is going to be actually in the advertising role. So we need to really fix this and change it from 100, what was it again, 141 to 7.6. Sorry, this was 100. So you can see 141 to 7.6. That's about 20x factor of reduction. So again, that will be one trick we will do in the application to optimize for low power. So now I will switch to the actual measurement on the kit to actually get us these two numbers. I connected my development kit to my PPK2 Power Profiler Kit 2 in ampere meter mode. This is the same DK that I used in the previous videos, though I did make one adjustment. You can see here, so I removed this jumper, which is for the current measurement, and I cut, there is a solder bridge here called SP40 that I cut. There is a link called Preparing a DK for Current Measurement provided in the slides for details on how to do this if you're using another development kit. So on another development kit, it could be a different solder bridge, or it could be that you don't need to do anything. So refer to the link there for more details on how to do it on your development kit. Alright, so open nRF Connect for Desktop, and from nRF Connect for Desktop, open the Power Profiler. Let's bring it here, expand it, and then select the Power Profiler kit. So that's the kind of like desktop interface, and you can see it's in ampere meter, and the enabled power is on. So that's kind of like bring on and off power to the kit, and then we can start. Alright, so let's give it a 10-second interval and get an idea of the kind of like average current. So the average current is way more than we expected, which is 141, right? And you can see there's this base thing here that is keep popping. That's the signal that tells us that there's something that is not in line with the expected kind of like current consumption from the online Power Profiler. And this is due to the UART logging that is enabled by default in the nRF Connect SDK samples or applications. So that's the first thing we need to do before we actually dig into the advertising interval. We need to first remove this unnecessary debugging kind of like power cost, because when you launch this product into the actual kind of like live, you don't need debugging to be on. You must disable it. So let's just take a screenshot of this so we can compare it to what will happen after we disabled logging and other kind of like unused peripherals in our oh, that's too big. Let's just take a screenshot to this here. All right, so next I'll move to VS Code and change the disable basically logging and unused peripherals, so we get rid of this kind of like wasted power. All right, so we're back in VS Code. Let's go to the Explorer view and let's kind of like make a copy of this one. Paste, and let's just call it prj underscore release. Okay, and I could have modified this one, but I'll do a cleanup later for the files from the LBS. And now in this file, what I'll disable logging from here, and I'll also disable the serial drivers, so the UART drivers basically. So in here I disabled the serial drivers, and then these rely on it. So instead of getting some warnings that this condition is not met, we just disable also the console and the UART console. And while we're here, I can also disable unused
peripherals. And with that, we can make a new build target for the development kit that we have. So I'm using this development kit. If you're using a different development kit, you need to choose it from here. change the base configuration. So I'll use the release, right? The one that I just made where the serial drivers is disabled. Okay. Then this one, let's just call it release and then build. And once the build is complete, I'll flash it to my development kit and go back to the Power Profiler application to see the measurements, how it changed when we actually disabled the serial or the UART drivers and also the unused peripherals. I'll speed up this part. Okay, build is complete, and I flashed the new build release, the one that is using the prj release.conf, to the board, and let me show you the new results. Okay, so you can see it's way improved than before. We got around 700 before, and now it's in line with the expected value from the online Power Profiler. It's actually better. So let me just take a screenshot. This is the previous one when we had the unnecessary debugging consuming a lot of energy, and that's something you don't want when you deploy your product. Debugging should only be used when you're actually developing. But let's take a screenshot of this so you can track of the improvements we're doing. And then after this, let's change the advertising interval that we discussed before. So I'll switch back to VS Code to continue on the power optimization for the advertising interval part. Okay, so let's do the advertising interval now. So I have also mirrored my phone, and I just want to show you how you can read the current advert. So now you can see the default one is about 100. So you specify in the code the max and a minimum, and it's implements it. The peripheral has full control on the advertising interval, unlike connection parameters where it's more dictated by the central. The advertising interval, on the other hand, is something you have control on the peripheral. So you can see now the default one we have from the LBS sample is around 100. We will change it because we saw there's a big significant change or gain in the power optimization if we do it. So the way I do it, I'll define two kconfig symbols for it, one for the max and one for the min. I mean, you can implement it the way you like it. So I just actually put them here, okay? And then in the code, I will simply define, so where we're setting the connection, it was in main. So I'll define this here. That's defining this parameter of this type, and then we're referencing these min and max. And then, sorry, where did we set the 100? The one you saw, it was actually through this. It's defined in this define. Okay, so you can see these values are set here, but now we have our own parameter, so we will do it here, and that's it. That's all you need to control the advertising interval. Just define this variable and then pass it to the appropriate function, and then I defined it in kconfig, so it's more organized, and let's just rebuild and flash and see the output on the Power Profiler. We did a pristine build because I've changed the config files. I'll speed up that part. Okay, so the flash is complete, and you can see now the sensor node. It's now the advertising interval has changed to about 3 seconds, and then if we see the power consumption, it's way better than before, right? So it's in range or in expectancy to what we saw in the online Power Profiler, and that's one of the tricks we can do to power optimize the device. And when it comes to these max current, you can also adjust that, but I don't think I'll have time to do it now. But you can control the TX power. You have good control over it. So if you're expecting the central and peripheral to be in certain range, you can adjust the kind of like DX power to be lower, so this kind of like max can go down instead of using the default values. I think that's decent enough for now. Let me also take a screenshot of this so I can put it in the slide. So that's enough for the advertising phase, and let's just move to the connection kind of like scenario of the device and also optimize that part. All right, so let's connect to the device and see the scenario which is in connection. We did the advertising kind of like optimization, and now let's do the connection. And again, I'm just kind of like barely scratching the surface here of the things you can do to optimize your application. So we're connected. You can see kind of like the power consumption have changed because you're now in a connection state. And something to note is like this connection parameter update. So there's this auto feature that you can enable in the firmware, which is enabled by default, that you request a preferred kind of like connection parameters. But again, the connection parameter is something dictated by the central, not the peripheral. So you, as let's say you develop your own mobile application, you can control that. And you can see here, if we request connection priority, you can set it from here, low power, and you can see it's way better than the default one. And the application will behave exactly as before, right? So we can actually read the, what's it called? The environmental sensor. You can still read them and everything exactly as before, but it's more kind of like power optimized. So what we will do in the application is kind of like set a more power kind of like friendly connection parameters and request them from the central. Let's do that. Okay, so back in VS Code, let's go to our PRJ underscore release, and then we can actually add these lines for requesting low power connection parameters, and then we can build the application, the build release kind of like configuration, and then flash it to our development kit and see the kind of like connection phase of the device. So we're expecting the central to respect these values, and then you can see the default connection parameter will be low power. So I'll speed up the building parts. Okay, so build is complete. I flashed it to the device and then made a connection, and then you can see now the connection parameter update is by default using low power kind of like configuration. And if we take a look at the power profiler app, we can see it's kind of like way more optimized than the default values that we got from before. And we can also, by the way, do the same thing in the online profiler. So there is, you can choose the kind of like connection kind of like role and kind of like get an estimation and also compare it with these values based on the configurations that you have. All right, I think we're ready now to move to the slides again. In summary of this video, we learned a way to get an estimation of the power consumption of a Bluetooth low energy application using the online power profiler. And we also learned a way to measure the power consumption using the affordable PPK2. And then we applied some basic tricks to optimize our application for low power, which is basically disabling logging and changing the advertising interval and the connection requesting connection parameters. There's still a lot of things you can do to further optimize your application, and that's bring us to the next video, which will be about DFU, device firmware update. So how can you update the firmware of your device when it's kind of like deployed without having an actual debugger? So most of the product don't actually have debuggers. The application need to have a mechanism, a bootloader, and a mechanism to do FOTA, firmware over the air updates. Let's say you want to further kind of like optimize your application for low power, or there is a bug, or there is a security vulnerability. That's the mechanism that allows you to kind of like patch it and fix it. And that will be the focus of next video. So thank you very much for watching, and see you in the next video.